Hello everyone, welcome to the fourth video in the CKA series. In this video, we are going to install Kubernetes from the scratch, step by step, and I'll explain why we do each step, not just what commands to type. If you are new to Kubernetes, this video is for you. By the end of this video, you will understand what components Kubernetes needs, successfully install a working Kubernetes cluster, and verify that it's actually working. So let's get started. Kubernetes looks scary until you install it once. Let's dive into the installation steps order first. When we install Kubernetes, we are installing the brain, which is the control plane components, the muscle, the worker node components, and a way to talk to the cluster. So you can install Kubernetes by using various methods, Minikube, Kind, and Kubeadm, just to name a few. For the sake of CKA exam, we will use Kubeadm to install our first Kubernetes cluster. In this video, I have created a Kubernetes cluster using the following. We have two Debian Linux VMs with 2 CPUs and 2 GB of RAM each. For the cluster to run smooth, I recommend you using at least 4 GB of RAM in your control plane node. And then we have given unique host names to the two VMs, full network connectivity, that means the two VMs are connected to the internet. They have connectivity between each other, and the two VMs can also be reached from the host, which is the Mac operating system in my case. Okay, so in the quest of installing Kubernetes cluster, the very first thing that you install is the containerd. As per the ship's analogy that we talked about before, containerd is nothing but the engine room of your ships. So we will be installing containerd first. After containerd is installed, we will be installing the Kubernetes tools such as Kubeadm, Kubelet, and Kubectl. Well, as mentioned before, Kubeadm is the tool that we will use to bootstrap the cluster and to initialize it. Kubelet is the captain of your ship. It runs on every node. Kubelet runs on every node and starts the pods. Kubectl, it's the command line tool to interact with your cluster. Then we will initialize the cluster because we have installed Kubeadm. Then we will configure Kubectl to be able to access our cluster. And then we will be installing the pod network. We will be using a CNI plugin called Calico for the sake of CK exam, but you can also use Flannel. The difference between Flannel and Calico is Calico supports your network policies while Flannel doesn't. Remember that for your exam. And then after everything has been installed, we will verify that our installation actually works. And then once we have verified that the cluster is working, we will be joining the worker node to the cluster. Let's start by creating two Debian virtual machines. One will act as the control plane, named control plane 02, and the other one will act as a worker node, named worker 02. For both the VMs, I'm setting 2 virtual CPUs, 4 GB of RAM, and 20 GB of disk. Nothing fancy, just enough to run Kubernetes comfortably. Right now, both VMs have one interface, one network interface that is connected to NAT. Let's wait for the virtual machines to power up. Now once they are up, I'm gonna add my user to sudo group so I don't have to switch the user every time. Let's verify. Now I'm gonna update the packages. And then I'm gonna install SSH so we can remotely connect. Going to do the same thing on the worker node. Now, after I'm done with worker node, I'm gonna power off both the VMs so that we can configure the networking on both. Now, I plan to configure two network interfaces for both of these VMs. One will be connected to host-only network and the other one will be connected to NAT. So let's configure the host-only network first. I'm gonna use the IPs between 10.0.11.10 to 10.0.11.100 and I'm gonna name it as host-net. We will be connecting the first NIC of each of the VMs to host-only network, and the NIC2 will be connected to NAT network. Host-only network will be used by the virtual machines to host-only network will only allow communication between host machine and the VMs and also between the VMs themselves. And the NAT adapter will be used to connect to the internet. It will provide the VMs the access to the internet. So this separation is very important and mimics the real world setup. After that, we will power up the virtual machines. And then after the virtual machines are up, we will check the network interfaces. Now remember, host-only network is not configured with the DHCP. So I'm not expecting an IP on the host-only network. So as you can see here, ENP0S3 is your host-only network, as that's the first network adapter. We can see it is up, and ENP-S08 is your NAT connected adapter, NAT network connected adapter. That's we can see that its status is also up. However, the difference is ENP0S3 host-only adapter does not have an IP address assigned to it, while the NAT adapter, which is S8, has got an IP assigned to it. So currently, our VMs should have connectivity only to the internet, but they wouldn't be able to ping each other because host-only network adapter is without an IP address at the moment. So we're gonna configure that first. We will configure the IP on the host-only adapter, which is ENP0S3 on both the VMs. We will be assigning the IP address 10.0.11.20 to the host-only adapter of the control plane 02, and for worker 02, we will be assigning the IP address 10.0.11.30 with subnet mask /24 on both the VMs. We will restart the networking service for the changes to take effect. We see that both of the network interfaces are now connected. Doing the same thing on worker 2. Now comes the fun part, testing. We need to make sure that both of our VMs are able to reach each other. They are also able to SSH into each other. And once we see that the connectivity is established, we will update their etc host file with the names, with the name to IP mappings. Now we need to repeat this test from the host machine as well, which is my Mac. So my Mac should be able to ping both the VMs and SSH into both of the VMs. Now here's something interesting. Earlier, I had VMs with the same names, worker 02 and control plane 02. My Mac saved their SSH keys because I connected with those VMs through my Mac. Now, when I connect to the new VMs with the same names, SSH sees a mismatch and throws a MITM warning. MITM is man in the middle attack warning. Now, this is actually a security feature. To fix it, just delete the old keys and reconnect. SSH will save the new ones. Connecting to control 2 through the same error, so I'm gonna do the same thing. Comment out the previously saved SSH keys. Now the moment I do it, I'm able to connect to control plane or SSH into control plane. Now it's time to prepare the system for installing Kubernetes. And how do we do that? Let's go to kubernetes.io and find out. Once you are on kubernetes.io page, search for installing Kubeadm. Now we are looking for Kubeadm because this is the tool that we are going to bootstrap our cluster with. And this is in line with CKA exam. CKA exam, you will use Kubeadm to bootstrap a Kubernetes cluster. Now this page over here, installing Kubeadm, is the installation guide for Kubernetes. This particular page gives you the installation guide for Kubernetes version 1.35. You can see the previous versions of Kubernetes installation guides are also listed over here. If you do not plan to install version 1.35, you can click on the other versions Kubernetes install guides over here and proceed following the steps in them. For example, like this. So this one is for Kubernetes version 1.31. But in our case, I'm gonna stick to version 1.35. So let's go through this document quickly to see how to check whether our environment is compatible or not. And if it is not compatible, then what do we need to do to make it compatible? So we need to check that our VMs at least have 2 gigs of RAM and 2 CPUs assigned to them. We also need to make sure that our Linux is compatible. How do we ensure that? So Kubeadm project supports LTS kernels, and they publish a list of the supported kernels over here. You can run this command to check the version of your kernel and figure out in this list whether your version is compatible or not. So we see over here that 6.12 is compatible. If we run uname-r command on our VMs, let's see what do we have. So you can see we have 6.12 version of Linux kernel. So this particular VM is supported. We'll close it. Scroll down in the list. Check network adapters. We need to ensure that port number 6443 is available. So we'll just copy and paste this command into our server and see what we get. We are getting connection refused, which means that there is no other service which is running on port 6443 on this server, and in the absence of any service, the port is closed. So that means the port is available. Let's scroll down. We need to check our swap configuration. Kubernetes wants you to disable your swap partition, or if you have any swap space on your operating system, it needs to be disabled. The command to do that is swap off -a. This would disable the swap temporarily, but in order to disable it permanently, which we should, we need to comment out the line containing swap in etcd fstab file. Let's take a look. Now, once that is done, we are at a point where we are ready to install the container runtime. Let's take a look how to do that. Click on the container runtimes here. Open that up in a new tab. We are going to use containerd as our container runtime. Now, what is a container runtime? Now, as we have seen before, containerd is nothing but the engine room of the ships that power everything up. Alright, now let's talk about an important concept, C group drivers. Don't worry, this sounds complex, but it's actually very simple. Think of C groups like resource manager. They control how much CPU and memory each container can use. Now in Kubernetes, the kubelet manages pods and container runtime runs the containers. So both of them needs to agree on how to manage resources. Here's the key point. There are 2 ways to manage C groups, C group FS and systemd. And both must use the same one. Why? If Kubernetes uses one and containerd uses another, the cluster becomes unstable. Think of it like this. There are 2 managers tracking employee work hours. If one of the managers uses Excel and the other one uses a notebook, then things will go out of sync. So we make both of them use the same system. What should we use? Well, if our system uses init system as systemd, then we must use systemd C group driver. How do we find that? By running the ps-p1 command. If you see systemd here, that means init system is systemd. When it's set to systemd, use systemd C group driver. Good news is when we install Kubernetes using Kubeadm, it automatically sets Kubelet to use systemd. So we don't need to worry about Kubelet anymore now. What do we need to do then? Only one thing. Make sure that containerd also uses systemd. And we do that by updating its default config after its installation. How? We will see that further in the video. So it's time to install containerd. Let's prepare a separate folder to store containerd files before we go ahead and install them. So we have chosen containerd to be our container runtime. And if we will scroll down further in the document, it will give us some more things to configure on our OS before installing containerd on it. First and very foremost thing is enable IPv4 packet forwarding. This is important because without it, packets won't be forwarded between your pods running inside the OS or from your pods to outside the containers, to outside the virtual machines. They wouldn't be forwarded. So it's important to enable this port forwarding first. To do that, we need to edit this particular file. If this file is not there at this location, then you need to create it. Let's see that. In our case, k8s.conf wasn't there, so I'm creating the file. Now I'm going to add two more entries in this file so that you are aware of these. Modern kube clusters don't need them, but they were needed in the past. I'm just letting you know about these things so that just in case if you get these things in your exam, you don't be shocked. Now these were needed because without them, the pod-to-pod traffic bypassed IP tables. There is no firewall between pod-to-pod traffic, which was dangerous because in that case, our traffic between pod to pod was not getting scanned or was not getting filtered through the firewall. Those parameters are these. These are called the bridge parameters, which force the packets between pod to pods through the IP tables, which is the firewall on your Linux operating system. Now after that is done, let's verify that they have loaded. Oh my god, we see that those two extra parameters which we put in that particular file has not loaded. Why? Because in order for them to load, they need a particular driver called brNetFilter. Without that driver, those two parameters are not honored. So let's load the driver first. Now modprob is the command to load the driver, and soon after we loaded the driver and ran sysctl --system command to see the parameters in use, we see that netbridge.bridge nf-call IP tables is equal to 1. Those parameters have loaded. You can see them at the end of the results. Let's go back to the document and come to the section container runtimes. We have something over here that's called getting started with containerd. Once we click on it, open it in a new tab, and it opens up a Git repository for containerd. Now this is the page wherein you will have all the instructions to install containerd. It also contains links to the packages and dependencies that we need to download along with containerd for it to install successfully. Let's go through this step by step. First step is installing containerd. In order to install containerd, we need to download its package. Its package is here on this link. So open it in a new tab. Go to tags. Choose the version of your choice to install and select the package to install as per your system. My system is AMD, so I'm going to choose this. I'm going to copy the link and use the wget command to download the package. Once the package is downloaded, I'm going to run this command to install containerd. After containerd is installed, I intend to run containerd via systemd. So I'm going to download this particular file from this link and install it over here at this location and run these commands to load it as a daemon. Now runc is one of the dependencies of containerd, which can be downloaded from here. Go to tags, choose a version of your choice. I'm gonna choose version 140 and select the version that suits your operating system. So AMD is my system. I'm gonna copy this link, paste it in the OS with the wget command to download it. Next is installing CNI plugins. Those CNI plugins are over here on this link. You do the same thing again. You go to tags, choose a version of your choice. I'm going to choose 1.9.0 and install the package, download the package, which is for my operating system. And just like that, we will be installing containerd. Let's take a look at it. That's containerd getting downloaded. After it is downloaded, I'm going to run the command, copying it from the same GitHub repository of containerd to install it at a specific location. Now I'm going to run containerd as a systemd service. So downloaded the containerd.service package. I'm going to place it going to place that at a location indicated by the install guide, and then run the commands to reload this daemon. Now containerd has been installed successfully and is running as a service. Now it's time for runc to be installed. Now I'm installing runc. Now it's time to download the CNI plugins. That's the command to verify that runc has been installed successfully. You run runc -- version, and soon after we will download the CNI plugins and install them. Now once it is installed, let's go back to the document of container runtimes. Now over here the document says return to this step once you have created a valid config.toml configuration file. Config.toml is the default configuration of containerd. Let's create this file first. And once we have the default configuration of containerd, we are going to load it at this location into config.toml file. How? Let's take a look. Config.d containerd config default is the command to load the default configuration of containerd, and now this is the command by which I'm going to load it into the config.toml file. Now we are going to edit the config.toml file, and this is the place wherein we are going to update the systemd driver. And also we will be updating the sandbox image to 3.10. I'll show you why. Going in the document below, this document is asking us to configure the systemd C group driver, and to configure it we will be going under for containers, for containerd versions 1.x, which is the one we have version 1.7. We will be looking into the config.toml file and edit this particular location and set systemd C group to true, which is what we did. If we will scroll down a little bit in the document, we will see that the sandbox image needs to be set to 3.10. Once we have done all of that, we will restart the containerd service. Now, after containerd has been installed completely, let's go back to the initial document of installing Kubeadm. Let's scroll down a little bit over here. Now, after containerd has been installed successfully, it's time to install Kubeadm, Kubelet, and Kubectl. Now, Kubeadm, this is a tool that we will use to bootstrap the cluster. Kubelet, it's the component that runs on all the machines in your cluster and does things like starting pods and containers. Kubectl, it's the command line utility to talk to your cluster. We need to install all these three components into our cluster to initialize it. How? Let's take a look. Scroll down in the document over here to this section. We have Debian based distributions, which is the one that we are using, the operating system. So we will be updating the package, downloading the dependencies, downloading the public signing key for Kubernetes package by running this command. Just copy and paste over here in the OS. Then we will add the appropriate Kubernetes apt repository by running this command, and then update the apt package index. And once we have the repository added, we will be running this particular command to download Kubelet, Kubeadm, and Kubectl. Let's take a look at all of this in action. So I'm updating the package list as per the document. Then we will be updating the dependencies. This one. Then download the public signing key for Kubernetes package. Done. Then add the appropriate Kubernetes apt repository and then update. We can also take a look at the versions of Kubelet, Kubeadm, and Kubectl which are available to download here. If we don't mention a particular version name in the command, then this particular command is going to download the latest version of all these packages, which is what we're going to do. And once these packages have been downloaded, we will mark them on hold so that they don't get auto updated. And last, we will be enabling Kubelet on this control plane node. We will have to repeat the same steps for the worker node, but first of all, let's create the cluster. We are going to use the .20 IP for bootstrapping the cluster. That's the command which you use to bootstrap the cluster. As you can notice in the command, we have mentioned two arguments. First argument is to specify which IP do we want to use as the API server. This is the IP wherein the cluster will be listening on. And then the pod network CIDR. So we define the IP range or the IP subnet of our pod network. So all the pods which will be getting created in our cluster will have this IP or will have IPs from this particular range. All of this is mentioned over here in the document. If we go further down, it says use Kubeadm to create a cluster. We go there and scroll down just a little bit, and there you are. This is the command to bootstrap the Kubeadm cluster, Kubernetes cluster. We have used pod network CIDR as one of the arguments and API server advertise address as another argument. Now we had to do this because our server has got two IPs. So we are defining explicitly over here which IP should the cluster be using to listen on. It's installing the cluster. You can read it over here, everything that it's doing. It's creating all the components of the cluster. Now, once this is done, you should see this message: your Kubernetes control plane has initialized successfully. If you don't see this message, that means something has gone wrong, and you will have to then figure out what's wrong with the cluster. For us, because we did everything the right way as it was given in the document, the Kubernetes cluster has been initialized successfully for us. Now, you see these commands. We will be running these commands as a regular user to be able to use the cluster. Copy those, paste it as a regular user. So I'm going to exit as the root user, be logged in as Ravi, put in the sudo password, done. Now as root, it says alternatively, if you are a root user, you can run this particular command. I'm going to export the kubeconfig file at this location. Once we have done that, it's time to deploy our pod network. These commands, kubectl get nodes. This is a command to see how many nodes does your cluster have. All the nodes should be under the ready status. Currently, our control plane is under not ready because it has just been initialized, and it takes a while before the control node becomes ready. Kubectl get pods -a. This is a command to list out all the pods that are running in your computer, in your Kubernetes cluster. We will be going through these commands in much more details in the upcoming videos. For now, just keep it in mind that these are the commands that you need to execute after deploying the cluster to verify that everything is fine. Core DNS pods are under a pending status because they will become running only when the pod network has been deployed. And so far, we don't have a pod network deployed yet. Make a note of this particular Kubeadm join command, because this is the command that you use to join the other nodes to this cluster. We will be joining worker node 2 using this command to the cluster after it is ready. So I'm gonna store it in a file temporarily. This particular token will be valid for 24 hours. After 24 hours, this token is going to expire and we will have to generate a new token to join the new worker nodes into the cluster. That's the pod network that we are going to deploy. We are going to deploy Calico. So if we scroll down just a little bit into this document, we will see the section installing a pod network add-on. Scroll down, installing add-ons, click on it. This is the document that has all the supported networking add-ons. We will be using Calico because Calico supports network policies, as that is one of the CNI plugins which support network policies. To download it, click on Calico on that page. You will be landing on its website. Go to its GitHub. It will take you to GitHub repository. Look for manifests folder in here. And you will see Calico's YAML in here. All you need to do is just click on it. It will be downloaded on your system like this. This is the file that we will use, the YAML file that we will use to deploy the Calico plugin in our environment. So all I've done right now is copied and pasted the Calico YAML. After the Calico YAML was created, I have run kubectl apply-f calico.yaml command. So this is how you apply a YAML file to create pods out of it. And then it is done. It has created 2 pods here, Calico node created and Calico kube controller created. These 2 pods will be responsible for our pod networking. Let's take a look. Now you see the pods are initializing. Let's keep an eye on the status of the pods and wait for them to keep running. I think it's done. Yep, all the pods are running except the kube controller, which is under the container creating status. Now it's running. Perfect. So the Kubernetes cluster has been deployed successfully with the pod network. Now we are going to do the same things in the worker node. We will install the containerd runtime, and then we will install the Kubeadm and Kubelet in here. Kubectl is not required because we will not be using the worker node to interact with the cluster. So Kubectl is the command line tool that helps you to interact with the Kubernetes cluster. We will only be installing 2 of the packages here, not all 3. Preparing the networking inside the worker node to handle the pod-to-pod network. Sorry, pod-to-pod traffic. Loading the BR net filter driver. Making sure that all the parameters have been loaded and are active. We are using systemd as the init service over here. Now installing containerd. Since I have downloaded all the packages already in my control plane node, I'm just going to copy them over to my worker node and install them. Those packages has been copied to worker node. I should be able to see them on the worker node now. Yep, all of them are here. Let's install containerd first, followed by runc and CNI plugins. Installing runc now. Verifying that runc has been installed successfully. Now installing the CNI plugins finally. Purposely, I'm not changing the containerd default config. We are going to install the Kubeadm and Kubelet. Now marking them on hold. Now the worker node has been installed. All we need to do is join it to the cluster. So we will be using the kubelet Kubeadm join command. Yeah, that one. We'll run it directly from the worker node. And just like that, it will be joined to the Kubernetes cluster. You can check the message. This node has joined the cluster. Kubeadm version. Going back to the control plane node to check the status of the nodes. We should see our worker node in there, but it's set to not ready. I know why, because we did not update the default containerd config on the worker node. Let's do that. Now I'm gonna update this default config.toml file with to use systemd drivers. And sandbox image to 3.10. Now soon after I make this change, we will go back to the control plane and check the status of the nodes. They should be ready. Yeah, restarting the containerd service. Let's go back to control plane. Kubeadm token create print join command gives you an updated token. that you can use to join the worker nodes into the cluster. Now you need to use this just in case you are adding more nodes into the cluster after 24 hours of creating the cluster. The tokens are valid only for 24 hours. We have discussed that before. Now we see the moment we ran kubectl get nodes, we see that both of the nodes are now in a ready status. And just like that, we built a fully functional Kubernetes cluster from the scratch, understanding every layer from networking to container runtime to cluster initialization. If you found this helpful, like, share, and subscribe. Drop questions in the comments. Thanks for watching. See you in the next one.